I have three example problems here of how we can use electrical power. So question number one on here, a toaster connected to a 120 volt source has 3.7 amps of current. So since I know the voltage and I know the current, I know P equals IV. So I can just plug in what we have. So I know I have a current of 3.7 amps and I have a voltage of 120 volts, and I can just calculate that directly. So I just multiply 3.7 times 120 and I get 444 watts. So that's going to be the amount of power that we have here. So 444 watts is our answer to number one. Number two then, a microwave connected to a 120 volt source has a resistance of 60 ohms. So if I look at the power equation, P equals I times V, I know the voltage, I don't know the current, and I'm trying to figure out the power. So I can't just plug in what I have right now because I don't have enough information. However, if we remember Ohm's law, V equals I times R, I can use that to find the current first. So I know that I have 120 volts. I don't know the current, but I have a 60 ohm resistor. So if I divide both sides by 60, I have a current of 2 amps. And so once I have that current of 2 amps, I can just plug that value in to the power equation. So power is equal to 2 amps times the voltage, 120 volts, which gives us 240 watts. Now that kind of leads to our third one here, because I wanted to see that there's a connection between Ohm's law and our power equation. In fact, that you can use both of them to solve different problems. So for this last one here, how much current is running through a 100-watt light bulb that has a resistance of 25 ohms? Well, I know from the power equation, P equals I times V, and I know that I have a 100-watt light bulb. I don't know what I is, I don't know what V is. But if I use Ohm's law, V equals I times R. I don't know the voltage, I don't know the current, but I do know that it's 25 ohms. So what I have here is basically a system of equations. So for some of these problems, you really have to look at the entire system in order to solve what you're trying to find. So in this case here, since I know V equals I times 25 pi, I can actually just plug V in for the V in my power equation. So I have 100 watts equals I times 25. So if I just simplify that, I have 100 watts equals I squared times 25. So if I divide both sides by 25, I have I squared equals 4. So I have a current, if I take the square root of 2 amps. That kind of leads to other ways to simplify our power equation, and that's just actually using Ohm's law. So we know that if I substitute V in for here, and if you look at what happens here, basically the power is equal to I squared times R. So we know P equals IV, but we also know that P equals I squared times R. That's something else I wanted to show you. And then lastly, if I actually just solved here for I and plugged it in there, because this is the other substitution we could have, we have V divided by R. Basically what happens here. So if I say, kind of follow along with what I'm doing here, instead of substituting directly in for V, if I divide by 25, I have V over 25 equals I. So if I substitute this one in for I instead of for V, we'd have 100 equals V over 25 times V, which means 100 equals V squared over 25. And that's the last equation that we really can get. If you look at what this is, power equals V squared over R. So P equals V squared divided by R. That's the third equation that we can actually get for power. And so all of those really just come from the combination of the power equation, the first one, and then using Ohm's law and just substituting in.